Good evening, everyone, and welcome to Howard Astronomical League, better known as HAL. Welcome to our Astro School. Tonight, we're going to be talking about good polar alignment, and our own John Nagy is going to be leading this session. So with that, once again, everybody, this meeting is being recorded. And John, over to you. Thank you very much for doing this.
Oh, sure, no problem. My pleasure. So welcome, everyone. Hopefully this won't be too basic for some and not too complicated for others. Just really depends on your background here. I guess let me start off by giving you a little of my background. I'm a 49-year-old engineer who was only recently introduced to telescopes in astronomy and astrophotography. I generally hardly ever look through my telescope, and some of you will probably tune out right now because I only ever hook up a camera and take pictures. But being 49 and just starting off in this hobby, that may seem strange to some. Everyone's hobbies and tastes change over time. In my case, the one thing that makes it even a little odder is that I've been working at the Goddard Space Flight Center for the past 26 years. So I've been intimately involved with satellites all that time. I guess I always figured that if I wanted to see a picture of the moon, I'd check the LRO website, or if I wanted a picture of a distant galaxy, I'd look on the Hubble website. But in June of 2019, I was tempted to go outside and see if I could see the moons of Jupiter when it reached opposition. So I grabbed an old Celestron 114 EQ Newtonian, ran outside, and took a little while to kind of get everything lined up. I had zero clue what polar alignment was at that time. It was a manual mount. So just as soon as I could get the moon or Jupiter into view, it would slide right out of the view for me. But when I finally did, my jaw hit the floor, and I was just surprised that I could see details on Jupiter and the four moons. And that pretty much hooked me. That was Father's Day weekend. Monday morning, went to work, thought about it for a little bit, told my wife, I think I want to buy a telescope. And, she said, well, don't spend $5,000. So I knew I had up to $4,999 to spend. So tonight we're going to talk a little bit about polar alignment and its real benefit on the astrophotography side. I think, it still has a benefit to visual observers as well. Definitely you need good polar alignment when you do astrophotography.
John, if I want to jump in here too, because
Sure.
We always want to make sure that for people who may be on this call who are new and they're not doing astro imaging and astrophotography, that observing is the core, and looking through the eyepiece, and as you said, good polar alignment, John, as you experienced, is really important for keeping the objects you're viewing in the view in the eyepiece, so you could enjoy it, study it, and if you're going more and more high power, especially on the moon and on planets, you'll see that it'll run right out of your field of view if you're not polar aligned properly. So polar alignment is every bit as important for especially high power observing through an eyepiece as well as through astro imaging. So thanks for letting me interject.
Sure, no problem. So tonight, I'll go over a little bit about what is polar alignment. Astronomers talk about it all the time. Why we do it, how we do it, the methods that I used during some testing that I had recently done. I'm kind of present multiple examples of some images of stars and how I achieved these particular images with a focus on the polar alignment and the error involved. So each step that I used in the 7 examples, I used a progressively finer, successively finer level, either using some tools to help fine tune that polar alignment. And then I added some additional equipment as it went on too. And then I'll show some conclusions that I've drawn from this experiment. In the backup, I have the actual equipment that I used. I have a listing of the equipment that I used. So if you're curious, you can look at the slides at the end. All images are of NGC 1960. It's called a pinwheel cluster. It's an open cluster of stars. Just happened to be a good target that night between the trees at my house, so I used it. And also I have a detailed test steps of the order that I did everything. I was keeping notes as I went, so that's all in the backup. So what is polar alignment? There's a little picture there of a typical equatorial mount, and what we refer to as the polar axis goes typically up through the middle of the scope, and it's the right ascension axis. So if you're looking at that picture, I don't know, can you see my mouse? Maybe not. How about now?
Yeah, we can see it.
Okay. Yeah, so the right ascension axis, rotates this way. The weights go up and over the top. The scope will go on the top here on the mount. You want to align that rotation axis with the axis of the Earth to be parallel to the Earth's axis. And the reason for that is the Earth is rotating every day, and at night the stars rotate generally from east to west. There are some areas at the south and the north where targets stay in view the whole night, but they still do a little circle. If you ever go out and look at the Big Dipper, you'll notice that throughout the evening, if it starts at maybe like the straight up above Polaris, by late at night it'll be over at the 9 o'clock position. So we use something called polar aligning to get the mount aligned, and it's really an essential first step in your night of visual observation or taking pictures. And like Phil said, it's it's useful in both visual and astrophotography. The better your polar alignment, the less your mount has to move or correct. It basically only has to correct for the movement of the sky and not the errors when you're misaligned. So I'm not going to go into great detail on the many different ways that you can polar align, but I'll talk to a few. And I'll explain the methods that I used and present the results of a little experiment I performed. There's a, let's see. You can, for one, you can do a rough polar alignment just by pointing your polar axis of your scope, your RA axis, towards the north. And the closer you can get to the north, the better. That's basically your initial rough alignment. You can take a more measured approach and use various measurements, a compass to align things. I've seen that performed. And you can take the next level and do some software alignment like SharpCap, where it helps you get your mount aligned. It does some plate solving so that it can know where exactly your mount is pointing, and then helps you to correct that to dial it in. And then there's even special hardware nowadays that you can mount it right on the front of your mount, and they have cameras like the PoleMaster or the iPolar.
John, excuse me, are you still on the same slide? Or have you?
Yeah.
Okay.
Yeah, I didn't have any pictures of them. Sorry.
Okay.
But the special hardware cameras, they have a wide field of view, and they look out the front of your scope, and they do similar things to the SharpCap. They have built-in star maps, and they recognize the stars, and they walk you through a simple process to get everything lined up. As with anything, with any of these methods, your results will vary based on your equipment, your skills. It doesn't tend to be a very long process once you kind of get the hang of it and have an idea of what you're doing. I probably spend maybe 10 to 12 minutes on it every night. People who are fortunate enough to have an observatory, they align their mount.
Did you hear that?
No.
Okay. Little polar alignment challenge. If you're in the northern hemisphere, you're pointing towards Polaris. We can see the North Star in the sky all night long. It's very close to the actual north central pole. It's an easy star to find just after the sun sets because it's very bright, and it makes our northern hemisphere polar alignment relatively easy. Our friends in the southern hemisphere, they have it a little more difficult because they don't have a bright star right near the southern ecliptic pole. I believe they use the Southern Cross to home in on that point. But it's the southern ecliptic pole, and the stars that they use are much dimmer in magnitude. So, and then I never really thought of this too much, but the people that are living near the equator, they actually have a pretty hard time. Our own
I'll take this to your room. So.
Victor Sanchez sent me this picture earlier today, and this is a picture of his telescope set up in Tanzania. He was 2.3 degrees south of the equator. And as you can see, his telescope is nearly level. So it would be really hard to find stars at 2.3 degrees above the equator. You know, first of all, you'd have to have a very flat area to even see sky at that level. And secondly, there'd be so much atmosphere, it would make finding stars really, really difficult. He said that the celestron mount adjustments only go to between 15 and 65 degrees in altitude or for latitude. So he had to have a special triangular fixture made to, if you look closely, you can see on the bottom corner of the right-hand part of the tripod, he's got a little bracket there that's holding that leg so that the whole tripod and mount doesn't fall forward. But sure enough, it can be done. I think he used some software to help align every day when he set up. So I thought that was a pretty interesting picture and worth showing because it's not something that many of us are very familiar with. So for this experiment, I missed a slide. I feel like I lost a slide somewhere. No, maybe not. Okay, sorry. So for this experiment, I went through and like I said earlier, I gradually increased the way that I did the polar alignment. The first thing was I just set my telescope out there as if it was just a camera on a tripod. And I took a 120-second exposure. You'll see that coming up. And then from there, I did a basic polar alignment through the mount. And then the next level, I added in a polar scope, which my mount has already inside. And then from there, I went on and used SharpCap, some software to help me dial it in. And then the last kind of iteration was I used the polar scope, I used SharpCap, and then I turned on Autoguiding, and I took a picture with that. And then just to see kind of how much of a difference a bad polar alignment would make, I purposely induced some errors to see how in this particular case, I was looking to see how the guiding software would handle large polar errors. So I guess we'll jump right in here. So this particular picture is is the NGC 1960 pinwheel cluster. Obviously, you can't see that at all. As you can see, a 2-minute exposure is pretty pointless without some sort of tracking, unless you're going for this. Maybe that's you're going for star trails and you're doing a super wide angle shot of stars, maybe rotating around the north ecliptic pole, something like that. But essentially, this is yeah.
Do you happen to know where this pinwheel cluster is in terms of RA and DEC?
I don't off the top of my head. I can check real quick if you like.
Is it close to one of the poles, or is it Is it?
No, I wouldn't have
Next to the
picked something
equator.
too close. Let me take a quick look here. I wouldn't have picked anything too close. It's actually Messier 36, and
In
it's
Auriga.
it's in northern Auriga constellation. So it's 5 hours 36 minutes in right ascension and plus 34 in declination. If that helps.
34, thanks.
Yeah. So, you know, like I said, this is essentially what you'll get if you just put your camera on a tripod, shoot up at the sky. I was using my Red Cat telescope. It's just a small telescope, short focal length. It's only 250 millimeters, so it's a lot of what normal people would have for, say, a zoom lens on their camera. And as you can see, 2 minutes is just way too long for no
John,
sort
we're
of
looking
movement.
at your background on your computer.
Oh, I'm sorry. Shoot, I guess I dropped out of.
It's a nice California nebula.
Thank you. Let me see if
Yeah, we can see your presentation with your notes. There you go.
okay. Yeah, I'm getting it. Are you getting presentation view now?
Yeah, we see the agenda.
Okay. Let me just get back to the slide you were on here. Right, so this one, you know, I knew that 120 seconds was going to be way too long, but I wanted to fix the exposure and make it the same through all these different tests that I was going to do on polar aligning. And I knew I needed a fairly long one because later on when the polar alignment gets better, I wanted to see if there was going to be any, you know, rotation in there. So this one I measured it, it was 3 degrees, 38 minutes. So I was relatively pointed, you know, where I needed to be. It could have been obviously a little worse. And this is just a picture that I ran through PixInsight. So with no guiding and no tracking, the mount wasn't moving. This is what you would get. You might be able to get away with maybe 30 seconds. I know some of the people out there that do wide field astrophotography, they probably get away with 30 or maybe more in a non-tracking mount with the super wide angle lenses. So then from there, actually I did a polar alignment, and this is the super basic one. It's through the mount pole. I actually took the polar reticle out of my my HEQ5 or Orion Sirius EQG mount. I'd never done that before, but I just looked through the little hole in there and did the best I could to get Polaris kind of near the center. And you know, it's just amazing what a little tracking will do for you, or turning on the mount and actually have it rotating. So, you know, I didn't change anything here. The polar alignment error is the same as the last picture, but I just turned on the mount. So it's now rotating with the night sky. And if you look close, you know, the stars, they're not good. They're still pretty stretched. But for someone who was doing just visual astronomy and having the mount moving, I'm sure the target would stay in the field of view for a good long time without drifting out. This was sort of a first for me, trying to look through that hole in the mount. I thought it would be a little easier. Turns out it's not as easy as I thought to look through there. But 3.5 degrees off is not too bad, I think.
That's how I always start. I start just looking through the hole, and then I do the SharpCap from that.
Yeah, I don't know about your mount, but mine has this little polar reticle, which you'll see on the next slide, and it helps immensely. I think I could probably, if I did this method with no little scope in there, I'm sure I could probably get a little bit better than 3.5 degrees over time with a little practice. This next picture here, I used the polar scope in my mount. As you can see, it looks a lot better than the last one. You know, to my eye, it's not too bad. The stars look pretty good. Again, this is just the looking through a little polar scope. I think I got a little lucky here. My polar alignment error is 0 degrees, 1 minute, 1 second, which I think is pretty darn close for just using a little stencil, which you're going to see on the next slide. Typically, I start this way every night, and I'm usually within 3 and 8 arc minutes off. So here's a little example of what I see when I look through my polar scope. Different brands have different pictures inside the little reticle. Mine happens to have a picture of the Big Dipper and of Cassiopeia. And then there's a crosshair in the middle with a circle around it. And basically what you do for polar alignment with a mount like mine is you put Polaris in the little circle, or well, first you look where the Big Dipper and Cassiopeia are on the night sky. So depending on the time of year, sometimes Cassiopeia is near the top, like in this example, with the Big Dipper opposite it. You rotate your mount to kind of align where Cassiopeia and the Big Dipper would be on like this picture. And you can't look through your polar scope and see those two constellations. They're too far out from the middle. But what you can do is, if you know Cassiopeia is at the 11 o'clock position, like you see here on this picture, and then the Big Dipper is going to be down at the bottom of the horizon. What you do is rotate your mount until you get those pictures in the same orientation. And then where the small circle is, right here, where it says Polaris, you put Polaris in that little circle. And like in this case, that would be the 6 p.m. position. And by doing that, it offsets the north ecliptic pole to right where the crosshair is. That's really all you have to do. It can take 30 seconds. You adjust your azimuth and your altitude bolts on your mount until Polaris goes into that little circle, and you're basically polar aligned. I do this every night. I'm sure a lot of people do. It takes just a minute or two, and I'm typically within 3 to 5 arc minutes. That's my usual position. In fact, I use a little handy tool on my phone called Polar Finder. And what that does is it tells you, if you didn't have these pictures in here and you just had a circle of showing the crosshairs and the circle with where the words Polaris are, it just tells you put Polaris at 3 p.m. or put Polaris at 9 p.m. or 4:05 or something. And you just put it on the circle. And that way you don't have to rotate your mount at all. So you just leave it right where it is. You use your azimuth bolts to move it left and right. You use your altitude bolts to move it up and down, and you just put it wherever the phone app says. In my particular case, the Cinta hand controller also tells you where to put it on that circle. So you don't actually need a phone to do that, to make that calculation. But if you don't have a phone and your mount doesn't tell you, you can always look at the picture inside the little polar scope.
Hey, John? If I
Yeah.
could interrupt again. So we have a wide variety of people on this call here tonight. And we have a lot of very experienced people, and then it looks like we have some possibly some relatively new people. And I want to let you know what John's explaining here is when you're just looking through the simple pole finder on your mount and you get it set up, if you're a planetary observer and you like looking at the planets, when you do what John just said here and keeps the planets in your field of view without having to adjust your telescope constantly, it makes the night worthwhile, for sure. It's a huge difference when you're not chasing Jupiter and Saturn around your eyepiece. So it's really, and you don't have to have anything fancy to do this. It's just looking right through.
Yeah, you do have to have a motorized mount, or at least a mount that has the little knobs that you turn. But even those, if you polar align them, you only have to turn one, and you only have to turn it a little bit. I'm sure it makes the night a lot more pleasurable looking at the moon or looking at the planets.
Hey, John, kind of along the lines of what Phil's just asking, I also have the star sense on my Celestron scopes. If you polar align combined with star sense, I don't know if you have it or if other scopes have it, but does that give you an even more accurate tracking?
I don't know. I haven't used the Star Sense, but I have a feeling that Star Sense is more for go-to accuracy.
It is.
So there's two different things we're talking about here. A polar alignment is not going to help your go-to accuracy. So you can have your polar alignment spot on and still not find a target in the center when you do a slew. It probably helps a little, certainly starting from the home position, pointing at the North Celestial Pole, but they're really two different things. I talk a little bit about that when I go on here.
Okay.
You know, so typically you polar align, and then the first step is either going to be to do a multi-point alignment or use Star Sense or something similar to kind of orient your mount and let it know where it's pointing on the sky, so that when you tell it to go to a certain right ascension declination, that when it gets there, you see the star that you intend to see at the center of your field of view. And you know how far off that is can make your night very frustrating.
Well, I think that the Star Sense is not going to improve your polar alignment or tracking in any way, but your polar alignment can certainly affect the efficacy of your go-tos when you're doing something like, because if you're not polar aligned, then it's just drifting over time.
Right.
And so the longer you go, the worse your go-tos are going to get, and your model that you're building with something like a Star Sense, or going star to star, that stays better the better your polar alignment is.
Right. Yeah, so I honestly haven't used the Star Sense. I'm familiar with it because I started my first scope was an Altaz Celestron SCT. So I've seen it, but I never bought one and tried it out.
Well,
Yeah, it definitely is helpful for me. And then I also have the Sky Safari because I'll control it through Wi-Fi.
Mm-hmm.
And it's just the drifting that I'm hoping to get kind of cleared up if I learn more about the polar like you're talking about here. But it's phenomenal as far as is what in view typically what you're expecting. And then, like I say, use Sky Safari app for the actual where do I want to move it to versus the hand controller.
Mm-hmm.
And it works out pretty well.
Yeah, I mean, my experience was, I started out with the Celestron Altaz mount. It had go-to built in. That's what I wanted. You would have to do some sort of multi-point alignment with it, either a 1-star or a 2-star, or a sky align, which is all what Celestron calls their alignment process. And if you did that well, then you did a go-to on your hand controller to whatever star or object you were trying to see for the night. And if you did a good job, you were pleasantly surprised when you saw some faint object, maybe a globular cluster or something in the center of your field of view. And, that, in my opinion, when you're first starting out, it really helps to not have that frustration to, look through the eyepiece and just see stars. Because if that's all you see, you have no idea where you're pointing sometimes. If you do start with something like a 6 or an 8-inch SCT, it's like looking through a soda straw at the sky, and it can be very frustrating if your mount isn't aligned correctly. And then adding the polar alignment to that, if you are polar aligned, then things should stay in the field of view much, much longer, and you won't experience that drift where things are kind of working their way off the side of the screen.
There's another factor with drift, and what you could be extraordinarily well polar aligned, but if your telescope is not balanced properly, it's going to cause a problem with drift, and it puts a drag on the motors. So you have to, before you go to polar aligning, you need to make sure your telescope is balanced, and that's a kind of a side session in itself, but it's adjusting the weights so your telescope is which either direction it is. When you let go of your telescope, it should not rise or fall when you have it horizontal to the ground. So right, so and that does cause a problem even with really good polar alignment. Is if your If your balance is off, that will do it. And also, if you've accidentally knocked out your deck motor cable, that will do it too. But that's a different story.
What about leveling? How does leveling fit in if you're not perfectly level?
So, I mean, I always level my tripod. I usually have like a little 6-inch level, little bubble level that I level my tripod, but I have seen some YouTube videos that if you're properly polar aligned, it really doesn't matter. I mean, the guy took his tripod, he put a brick under one of the legs and lifted it up like 3 inches, and it didn't make a bit of difference. Polar alignment, you know.
Well, Victor's wasn't level either.
I was about to say.
Hey, Victor.
It doesn't have to be level.
Yeah.
It has, if you're polar aligned and you do your star sense or your other training of the mount, you're good to go.
Yeah. I think a lot of these steps in astrophotography or astronomy with the telescope mounts, you know, there's a lot of little steps. Once you learn each of those steps and put them together, you know, it gets easier each time you do it, obviously. And each little step that you learn makes it a lot better in the end. So, you know, if you're properly aligned, but you're not, but the mount doesn't really know where it's at, then you're going to have certain problems. And I think it's a lot of little details that you have to put all together to get everything to work really well. Okay, so let's see. This was my basic step number 2 here. You know, I used my little polar reticle, and you can see it made quite a big difference. This is zoomed up here quite a bit. This is the center of the NGC, or the NGC 1960, the pinwheel cluster. For the next test that I did, I kept the same polar alignment using my polar scope, but then I further refined that with the SharpCap software. I think you could completely replace the software could completely replace the manual looking through the end of your scope. You certainly don't need it. I still do it every night because it only takes a few seconds to look through there. And when I first turn on SharpCap, I'm usually within like 3 to 8 arc minutes. So it's pretty close. I think if I was to skip that step, I'd probably be multiple degrees off every night, and then I'd spend a lot more time tuning it in with SharpCap. So it's an easy step to do. I have the little polar reticle inside the scope, and I do it.
John, are you going to describe how you do that with SharpCap?
Yeah, I don't really have. No, I guess I'm not. I mean, I can basically describe it.
Yeah. So, hey, Victor, and a week from Saturday is our next public star party, rain or shine. But if it's a clear night, maybe somebody will be able to do that demonstration using SharpCap when we're starting off the night.
Yeah, I mean, I can basically walk you through it, but I don't have any like a whole bunch of screenshots of the screen.
Yeah.
So what you do, and you can do this with either your main camera on your scope, on your main telescope, or you can do it with the guide camera on the guide telescope. I typically use the guide camera on the guide telescope, but I did take the time one night to try it with both of them, and it didn't make any difference which one I used. They both came out the same. But you open up SharpCap, you go to the tools, you hit the drop down for tools, and you select polar align. And what it does is it takes a picture. If it can find, hopefully it can find enough stars. In the lower left corner there, you can see a picture of the SharpCap screen. It'll tell you when it finds enough stars that it's done plate solving. Now it basically knows where your mount is pointing. Then it asks you to rotate the mount 90 degrees. In my case, I just use the motors on the mount. I hit the button to rotate the mount, and I sit and watch until my weights are horizontal to the or parallel to the ground, so I'm at 90 degrees. And then you hit the button and it takes another picture. And then it does another plate solving on that picture to recognize the stars and where they're at. And now it knows, okay, well, that star was here, and therefore it moved, you know, to this position. If you're perfectly aligned with the rotation axis of the Earth, your picture would just rotate like you were rotating a picture on your computer 90 degrees. But if those stars don't end up perfectly 90 degrees, then you know, SharpCap would know, okay, well, there must be a little bit of a rotation in there. So it figures it out. And I don't know if it's real easy to see, but down here on the bottom corner, it shows you your polar alignment error. In this case, it was 5 minutes and 29 seconds. I just grabbed this little image off the web. It wasn't one of mine, but and then it actually tells you which way to move the adjustment screws on your mount. So in this one, it says move left 1 minute 49, I think it says, and it says move up 5 minutes and 10 seconds. So I just turn the left, you know, the left knob on my mount until that reads 0, and I turn the up altitude bolt until it reads 0, and then you should have, in theory, a perfect 0 in the box here.
Now, when you do this, is there a particular plate? You do this after you've trained the mount, right?
I actually don't. No, I do it right from the get-go, right in the beginning.
And where do you normally have your scope pointing when you do it?
I start at the home position, so basically pointing towards the North Pole.
Wow! So there's enough stars there for it to do a good plate solve.
Yeah, I think, you know, it might be a bit of a challenge if you were using, say, an 8-inch SCT, because you'd have such a small field of view. In my case, I'm using a 50 millimeter, 200 millimeter focal length guide scope, so I think it's around 4 by 3 degrees. So with that big of an area of the sky, you know, I find plenty of stars. I tend to do maybe a 4 or 5 second exposure, and it'll find plenty of stars. 17, 18 stars, that's usually good. I think it needs between 10 and 15 to get them. So, you know,
Thanks.
Once you've rotated the scope, you know, now you're rotated 90 degrees and you've dialed it in. That's pretty much the end of the polar alignment. I shut off SharpCap and then I go about the rest of my night. I think I started to talk about it a little bit before. I think the next step you would do from this point forward would probably be an alignment to teach your mount, you know, exactly where it's pointing. I don't do that because I use software to plate solve where the mount is pointing all the time. So I skip that alignment step, and I'll be honest, if I had to rank all the things that I've done in the last year and a half, getting plate solving working was probably the thing that made the most difference in the stress level for an evening of taking pictures or looking at the night sky. That multi-point alignment was just a nightmare for me. And I guess maybe in my backyard, I'm working with a lot of trees, so I can't always find the right bright stars at the right locations. I don't have a huge patch of sky to look at. So just being able to tell the scope, go point here, and let it figure out like, oh, it's off by a degree, and then it fixes it. That to me is just, that was worth a lot of money, and it didn't cost anything. Plate solving, there's some free software out there, and it was just a great thing.
Do you
Magic.
have to do that? What do you use to do that?
I use a program called ASTAP, ASTAP. It's kind of, I'll say, I don't know, it's not embedded in, but it's it works in conjunction with NINA, which is nighttime imaging, something, astronomy. One of our guys in the club is actually a developer of this NINA package. But the APT package has plate solving built in. I think SGP has plate solving built in. So kind of a lot of the major packages can initiate a plate solve. There's other ways to do it. You can certainly take a picture and just upload it to the web. And that actually is the way I first started out before I started using Nina. I would take a picture, I would send it through my phone up to the astrometry.net website. It would take a couple of minutes and it would tell me what the center of my image was. And then I could take that and feed that back into my mount. And now that I knew where I was pointing, I could make a correction and get to the target. But certainly once I got it all put together with the control software, Nina, it made it just completely painless. You know, I just put in the coordinates of the target I want. I can put in six targets in an hour, and I don't even have to be outside. You know, the scope will just go from one to the next, and they'll be perfectly centered each time. So, plate solving is just like black magic. It just works. Let's see. So this was the. Let me get back to the program. This was the third experiment, or the third experiment I did with this polar alignment here. So, you know, at this point, I'm using the polar scope in the mount, and I used the SharpCap to get it dialed in. And I took the same 2-minute picture, and now you can see the stars are just so much better. They're round throughout the frame. They're not stretched in any way. This next picture is it's the same picture zoomed up. So it's a little hard to see because this is just one single image. They're not super sharp and clear, but you know, if you look at stars around the edges, they're pretty round here. There's no guiding going on. This is just a 2-minute exposure with my mount rotating on its own freely, but I have the polar alignment dialed in. That really helps. You know, I think the mounts themselves, they're fairly accurate these days, and they do a good job of rotating at the spin axis of the Earth, or the spin rate of the Earth, the rotation of the Earth. You know, just taking out that error, the polar alignment error, really helps them out. Okay, so the next one, I continued on. I used the same polar alignment. I used SharpCap to dial it in. So I got it down to 13 seconds of error. And then I turned on auto guiding. And auto guiding is where it's a closed loop. So you take a picture through your guide camera, you send that to some software. It's looking at a particular star, and it's not one picture, it's a whole stream of pictures. It locks onto one of these stars in the image, and then if the star moves a little to the left or a little to the right or a little up or a little down, this software called PHD2, and there's a couple other ones that do the same thing, auto guiding. The software will say, okay, well, the star moved a little bit to the left, so I need to send a command to the mount to either speed it up or slow it down, or command the declination axis to go north or south to put the star right back in the center of the crosshairs. Once you do that, you could theoretically go, you know, I don't know, 10 minutes, 12 minutes, 15 minutes. I think you can go as long as you want. You know, it comes down to, I guess, the accuracies of your mount, and how well it will accept the auto guiding commands, and how well it will stay on target. But it's a little hard to see, but this picture actually is just a little bit better than the last one. I'll zoom up on it here. It looks pretty much the same as the last one, but I think that's because I had pretty good polar alignment error even before I initiated the PHD2 auto guiding here. But they're slightly rounder here, slightly tighter stars.
Yeah, I think that looks much better than the last one. Can you check?
It's dramatically better.
Yeah.
What was that?
You don't have any elongation going on, or very little.
Yeah, these ones in the center, they're a little hard to look at. They almost look like they're elongated, but I think it's just that they're the brighter ones. And
Yeah, and you have two stars that are very close together. So
and this is also pretty long, pretty short focal length, so they kind of look like two stars are together in a couple places. So if you look at the ones around the edges a little bit more, you know, they're pretty round. I wanted to really see, I wanted to learn myself what difference the polar alignment error would make. So I knew using these techniques of using the polar scope inside the mount, using the SharpCap software, or like we mentioned, the iPolar or PoleMaster hardware, you can get really good polar alignment. But if you don't have those and you're just getting close, what effect will that have? So I tried to actually go the opposite. I used the SharpCap to intentionally increase the error. And but it's really easy to do because it's just taking pictures and it's telling you what the error is, and all you have to do is just crank the knobs. So in this particular case, I used the same target. I intentionally dialed in 15 arc minutes of polar alignment error. I had no idea what this was going to do. I wanted to keep the PhD. I guess if I would have known I was going to present this, I would have done even a lot more different little tests. But in this case, I kept the PhD2 software auto guiding with a 15 arc minute error. And I think it looks, pretty good. I had very good guiding during this time. If I go one picture forward here.
Hey, John.
Yeah.
I'm sorry I'm asking so many questions. I hope I'm not annoying.
No, not at all.
Do you happen to, it sounds like you may not have because you weren't planning to make a presentation out of it, but did you happen to notice or record which way your 15 minutes was off? Were you?
Yeah, I intentionally made it about equal in the two axes. I didn't just do it all in azimuth or all in elevation. I kind of split it, so it's like 45 degrees.
Kind of along the diagonal?
Yeah.
Okay, thank you.
Yeah. So here you can see the one-to-one zoom up on the center of the pinwheel cluster. And what I can say is I was recording some notes while I did this. I did set out with an objective. It wasn't to make a presentation for this group. It was just that, somebody, and I think it was somebody in HAL, asked me some questions about polar alignment, and I didn't know the answer. So I thought, well, maybe I'll take a couple hours one night when it was like a full moon night to, I wasn't going to be shooting pictures. I'll just take a couple hours and go out there. And it was relatively warm out that night, so it wasn't really painful to be outside. And I just, constructed myself a little test and did it. But with 15 arc minutes of error, I didn't really notice the guiding working a lot harder. But the farther off your error is, the harder the guiding, the auto guiding software has to work, because it has to account for those errors and correct for them constantly.
Can you toggle back and forth between your last one and this one?
What was that?
Could you possibly toggle between
Sure.
2 minutes ago and this one?
This was, 13 seconds of error. This is 15 arc minutes of error. There's certainly not a lot of change here. I guess if you were to look at maybe like these stars in the lower left corner here, like this pair is nice and close together. If I click back here, they look about the same. They might be.
It looks to me like your focus got a little softer in the second one.
Yeah, it could have. There could have been a little bit of a change, but you got to remember that was the one-to-one zoom up there. If you look at it from the full frame view, there's a lot of stars in here. It's a little hard to tell if they're out of focus. I think the focus was pretty good. I mean, I do notice some focus shift as the temperature drops, and I don't generally refocus, especially I did all these pictures within about an hour. So the last sort of experiment that I wanted to do is I just doubled the polar alignment error again, and I took it up to a half a degree. If we think back to that picture of, or I can just rotate back there. Let me go back. If we go back to this picture here, the difference between the center crosshair and this outer circle is, I believe, 0.4 degrees. So I induced basically that much error. I had the north central pole that far off, and PhD2 compensated for it very well. I'll zoom up on it here. And there again, you really can't see much difference in this one. You know, I tend to look at these stars down here. They look about the
Still
same.
round for sure.
Now again, I was only using a 250 millimeter scope. I think if you were using like a 2000 plus millimeter, you know, Schmidt-Cassegrain, you might see a lot more difference. I don't know. But I certainly was, I was actually pleasantly surprised to know that Autoguiding could handle that much. And I looked at the logs and I didn't see, you know, just a ton of corrections going on in the logs. So it's good to know that, you know, one software can compensate for some other human errors. You know, half a degree might seem like a lot, but if you're on soft ground during the course of the night, your mount could be slowly sinking every time you get up and move around or something. You could be, you know, it could be slowly sinking into the ground. It doesn't really take much to get your polar alignment to slip out to 10 arc minutes, 15 arc minutes, 20 arc minutes. I tend to set up in my backyard, and you know, I have to put it out in the middle at the night and then bring it back in the morning, and it's soft ground. I don't have a patio out there or anything, and you know, I do put some little hockey pucks underneath the mount feet so that they don't slip into the dirt. But yeah, it's good to know that the PhD2 can compensate for that. Unless you like star trails, if you're going for that effect, and you know, you need some sort of tracking of the night sky for anything but the wide angle or very short exposure photography, and you know, doing a good polar alignment or fine tuning your polar alignment can really help. There's a small little boost in magnification with that little reticle that's inside the scope. And it does have a little picture that really helps place Polaris where it needs to be. And you know, if you didn't go any further than that, I think you would get pretty good pictures. I feel like I could easily take 60 seconds, maybe even a little longer, without any sort of guide camera, guide scope, SharpCap, pole master, you know, just using the basic mount and a camera, and looking through the thing to the polar reticle to place Polaris. I think you could have pretty good results. If you're auto guiding, the extra accuracy of SharpCap or the hardware to really refine the polar alignment is maybe not necessary. If you have the capability, I wouldn't discount it as long as you're close. I mean, I think my two tests that I did that night really opened my eyes to the fact that, you know what, the good guiding software can really help, but it can't hurt to have it really well aligned. Certainly makes life easier for the guide software, and also you know, the corrections that your mount's getting told to do throughout the night. So that's really all I had. Sorry I didn't have more pictures on what you go through with the mount. I think that's probably something that you could maybe do in some slides, but I think it's really something that's better done either in person or in a video where you could watch somebody go through the process.
Right. Well, John, hey, well, thank you very much. I got to tell you, it was really, really good. And I'm really also impressed by the number of people and experienced people that came to the event tonight. I also want to thank those who joined from other clubs and other organizations who found out about this and dialed in here also. You know, these talks always lead to another one, and another good topic could be, we could be talking about plate solving and do some virtual demonstrations on how that's set up. And so I'm going to work with you guys on that. And John, you've timed it perfectly. You're right on target here with 3 minutes to the hour. Is there anybody else that has any questions or comments? Anything else that you'd like to see in Astro School moving forward? We have lots of expertise here in our own club, and we could find others. So Anybody have anything? Nothing?
I think if people send in your, you know, your requests, we can probably find between, there's a few of us that are pretty active. And certainly some that know a lot more than me. I'm only been doing this for 2 years, but you know, I'm sure we could put together some little classes on specific topics.
I'm just curious, have there been any sessions done on like specific software? Like you mentioned SharpCap, for example. You know, I'll use that, and I've got a couple other tools I'll use to take the images and stack them. And I've definitely seen some differences between the types of tools that are involved. Some process things better, some not so much, right? Has the club done anything like that to kind of
Yeah.
compare some tools or give some tips on here's a good setting for how much gain or exposure, that kind of thing?
Not to that level. We do have, as John mentioned in passing, Dale Gent, who's one of our leaders in the club. Also, now he's our observatory director, but he's one of the developers for Nina software himself. So he gave a quite extensive session on Nina that actually started out at 7 o'clock and it ended about 12:30 in the morning. People kept him going and he kept on going all night. But but we haven't done anything on comparing different software packages. That certainly could be done by having a couple of people get together and do things. We'll have to figure out, Michael, what would be the best way to do that? Would it be to just do something on one package at a time, or to, and have people delve into it and, go through each one of them, or maybe have a session that's more high level and just compare the features and benefits from one to the other? But I tell you, well, a lot of that is opinion, on what people are comfortable with and where they use it. So it's not really like a CNET test, if you will. But, those are all very good options, and we just need to put it on the schedule and have some folks that are willing to share their expertise with us with that. So
That'd be great. Is the Nina one recorded by chance? I'm new, so I'm not sure.
No,
if
it's not.
posted.
It
Okay.
wasn't recorded. So actually, this is one of the rare recordings because somebody asked me to do it before we got started, so I didn't forget. And so this one will be recorded, though. In fact, what I'm going to do right now is everybody can hang on. I'm just going to stop the recording, and then we can keep on talking. So let me just stop recording. Yes.